Now, after estimating the seasonal index, the next step in time series decomposition model is to estimate what we call the average seasonal index. How to estimate the average seasonal index and what's the logic behind that? So what if we take all quarter one values? So by that I mean this is a quarter one value, this is a quarter one value, and so on and so forth for 14 and 15, and let's suppose for 16, and so on and so forth, all quarter one values, right? And if we add them all together, and if we divide it by 1, 2, 3, 4, 5, 6, and 7, we'll basically get the seasonal index value for quarter one. Similarly, for if we pick all quarter two values from this data set and we average it out, we'll get the average seasonal index for quarter two, and similar for 3 and 4. In order to do this particular method, there is a smart way to do it. But for that, we first need to generate a dummy variable. By dummy variable, I mean, so we'll call it a dummy variable 1. So quarter 1, we are supposed to call it 1. Quarter 2, we are supposed to call it 2. Quarter 3, we are supposed to call it 3. Quarter 4, we are supposed to call it quarter 4, representing with the fourth number, and we'll replicate these values. So that is how we generate the dummy variable. So what are these 1, 2, 3, 4? These 1, 2, 3, 4 represents the value of quarter 1, 2, and 3, which we will use in forecast ahead. Now, once we do this, right here, our aim is to estimate average seasonal index. In order to estimate average seasonal index and the method which I just discussed, there is a smart way to do that, and for that we'll generate a small table right here. And what's this table about? This table corresponds to the average seasonal index value in a way that we'll call this column Q, and we'll call that average seasonal index. We'll call that quarter 1, quarter 2, quarter 3, and quarter 4. And we'll use a unique function that is used in Excel, and that is called the conditional average, or average if. Average if. Now, once I type in average if, it requires 3 values: the range value, the criteria, and average range value. So you see the seasonal index, which we estimated by dividing the actual value by the baseline. This will be called the average range because we are supposed to provide the average value for this particular value. The criteria, in criteria, we are supposed to choose these values, the dummy variable 1. And in average range value, in average range value, we are supposed to select the seasonal index. So how to proceed with that? So first, the range. So in range, we are going to ask Excel to consider these values right here. Okay. And then we'll ask Excel to pick 1 in those values. So Z4, so behind that particular code, we got the value 1, which corresponds to the dummy variable 1. So you see, in the range, we selected the dummy variable, and then we are asking Excel to pick 1 value from all this data set, and we're supposed to fix it. So I'm going to fix it F4, and this one to F4, comma. What should be the average range? The average range is right here. Okay, and I'm going to fix that one as well, and bracket. And if I enter that, so see, the average seasonal index for quarter 1 is basically equal to 1.65. So on average in quarter 1, the seasonality is 65% above the baseline. Now, if I drag it down, so all of these values, these average value, are estimated in a way that Excel took first all quarter 1, average it out. So the average value is a 1.65. Then for quarter 2, it took all the values of quarter 2 from year 2012 to 2018. And the average value is a 1.13, which means that the average seasonality, the average seasonality is about 13.9 or about 14% above the baseline. Similarly, quarter three average value is below the baseline, which is less than 1. And similarly, for quarter four, the value is below the baseline. How much is below the baseline? So it's about approximately 3% below the baseline, 3 or 2% below the baseline. Now, once we do this, we are simply supposed to copy these values and paste them right here in the similar manner, right? So this is how you estimate what we call the average seasonality index for each and every quarter. Now, once we do this, now we'll use this average seasonal index to deseasonalize this data. What do I mean by deseasonalization? By deseasonalization, this means that we are supposed to reduce these peaks and troughs in this particular data set. So all the depressions and all the progressions, all the peaks and all the troughs should be minimized. We should compress it. And that's what the deseasonalization means. So how to do that? It's once again simple mathematics. So we are supposed to call it a deseasonalize index data. So what are we supposed to do? Equal to whatever is the actual value, we are supposed to divide that by the average seasonal index and just drag it down. Now watch the impact. So if I plot this deseasonalization index and if I do that like this, so see, original data set, let me plot them together. So here you go. Let's select the data. So I'm going to retain the actual value alongside that this value right here. So you see the blue lines, right? That represents increased seasonality. However, the green one is basically that deseasonalize index in which we suppressed the seasonality. Okay, why are we doing this thing? In order to determine a trend, we first of all we needed to estimate the seasonal index. Then we are supposed to use this seasonal index to deseasonalize the actual data. Once we deseasonalize the actual value, then through regression, we are supposed to estimate the value of trend. And how to estimate the value of trend? Now, once again, I need to generate another dummy variable. And let's call that dummy variable 2. And this time, dummy variable 2 corresponds to time. So for this quarter 1, 2012, I'll call it 1. For quarter 2, 2012, I'll call it 2. Then next one should be 3 and 4. Next one should be 5 and so on and so forth. So it's basically the time periods, and I'll extend it down below right here. Okay. Once I do this, then we are ready to estimate the value of trend. Now, before proceeding towards trend, the trend is represented something like this. In time series decomposition model, trend value is equal to whatever is the y-intercept value plus the value of slope into what we call the time dummy, or in this case, we call it a dummy variable 2, which was simply 1, 2, 3, 4, 5, 6, 7 up till some particular value. So we can estimate the y-intercept value through regression, the slope value through regression, and we are supposed to multiply that with the time dummy or dummy variable 2, and we'll get the value of trend. So let's proceed with that. How to do this? We are supposed to go to data, and in this data, we got something called the data analysis tab. So let's click on that. So once we click on this right here, we need to find the regression right here. Click OK. So if we think about, and we are supposed to perform the regression. So this equation, this particular regression, which we are performing is between a dependent and independent variable, which in particular time is this time dummy variable is independent, while the deseasonalize index is what we call the dependent variable. So this will be your y and this one will be your x. So when we perform the regression, when we estimate the parameter of regression using deseasonalize index as a dependent variable and time dummy or dummy variable 2 is as an independent variable, we'll get the value of beta and alpha, and then we can estimate the value of trend. That is how we are supposed to estimate the value of trend. So now, once again, data and data analysis, regression, uh, input Y range. So which one is a Y range? This one is a Y range. So let's take them. So this is the Y range, and here you go. And just remember, I selected the title as well, and which is a string variable, right? Then again, what's the so this should be, so I'll just remove that reference. So your Y range, the dependent range should be a deseasonalized data. So we selected that from H2 till H30. So we are supposed to do the same range for the X input, which is independent. So this is dependent, this is independent, right? So the same manner till I30. So I selected the dependent variable till here. So I'm supposed to select the independent variable till here. Once we select this, we'll click label. So label means that the first observations are basically string variables, so they should not include that in estimating the regression parameters. And the rest, I'll ask Excel to give us the regression output somewhere around here. So let's suppose here, and click OK. Here you go. That's your regression output. The first thing which you should notice is something like this. The significance F value is 8.68 raised to the power minus 8. So check this value. If this value is below 5%, then this means the overall regression model is significant. Once it's, and this is highly significant, this value is with compared to 5%, it's a considerably small value. It's almost equal to 0. Then the second thing, once this is significant, then we move towards the intercept value and the corresponding slope value. So the intercept value is a 2.74, and let's go to the p-value. The p-value, this is also significant. This value is below 5%. So if we are considering 5% as significance level, so it's a considerably small value. It's a highly statistically significant. Same for the slope value. It's highly statistically significant. So this means we can use these regression parameters in order to estimate the trend. What if the value of significance F is more than 5%? So this means if we use these regression parameters in estimating trend, then our trend will basically give us wrong values. So the statistical significance of this regression model is paramount. Now, how to go about estimating the trend value? So I'm supposed to write here trend. And since I give you the trend equation, which is the intercept value is added with the multiplication of the slope value with the time dummy. And I am supposed to fix T26 cell because it's from this table. So each and every cell will have this intercept value. And similarly, T27 value, which is the slope value. So the first value is always the intercept value, and then DV2 is basically the slope value. So we'll fix that one as well and press enter and drag it down. So if we drag it down, now let's plot this value. If we plot this value, this will be pure trend. And here you go. That's the pure trend in this data. Now, all we need to do is the last step of this algorithm is, so we'll call that a time series decomposition model value. All we need to do is we need to multiply the average seasonality index, since I mentioned in the start of a time series decomposition model that it's a multiplicative model, with the trend value. And that's the forecast value corresponding to Q1 2012, and through a time series decomposition model, if we extend it across. So here you go. That is your forecast value. So now if we plot them all together, then insert, and here you go. So I'll select time period right here. And we'll remove the remaining one. So we'll just leave the actual data, and we'll keep the time series decomposition one. So here you go. So now the blue one represents the actual value and the gray represents the forecast value. And here you go. This is the forecast value. So now let's estimate the error in this forecast model. How to do that? We'll simply estimate that using the map methodology. So all I need to do is just take the actual values, Control C, and I'll paste them right here. And we'll take the forecast values, which are right here, Control C, and I'll paste them as values. And let's estimate error now. So we are supposed to estimate this model now, the map. So mean absolute percent error, which is equal to whatever is the actual value minus forecast value, absolute divided by actual value, sum them all up, and divided by the error term multiplied with 100. So this map methodology will give us the error in this particular forecast model. So let's estimate that. So the first step is estimation of error. So ET. So here you go, equal to this actual minus forecast. That's the first step. Let's drag it down. Then we are supposed to take the absolute error value, which is the second step right here. So this is equal to ABS error, and drag it down. And then we are supposed to divide the absolute error value by the actual value, which will give us the percentage error. So this value divided by whatever is the actual value. So in the first observation, we have about a 32% error, and just drag it down. Once we do this, then the next step, we sum it up. So sum of what? Equal to sum right here, and then estimate the value of n, which is error term. So that is equal to count if, and the error terms being this. So what's wrong in here? Count if. Okay, count if. COUNT, count. We'll not use count if, we'll use count, and 28, and finally the map value. So equal to this value divided by that. That means that whole of this numerator is equal to 2.40, and the denominator is equal to 28. And if we get this, so this forecast model has about how much? So if we convert that, approximately 9 to be exact, this forecast model will give us an error of about 8.61%. This is how we forecast value using time series decomposition model.